We're going to talk about inductive and deductive reasoning. Believe it or not, you actually use this every day in your life. We just did it in our examples. Just try not to trip. Here we go. So how can you use reasoning to help solve problems? Let's brainstorm. Why would reasoning help? Colt?
Critical thinking.
Critical thinking. What else?
You bring down your options.
Bring down your options, yeah. In multiple choice tests, you can look through and say, well, this is not an option, this is not an option. What else?
Make sure you don't jump to conclusions.
Don't jump to conclusions. What else if, let's say the question was, how many miles is it from Jacksonville to, this spot in Carolina, North Carolina, and you said 2.8 billion miles, okay? What would your logic tell you?
That's not right.
It's not right. It's not possible. Okay, so using logic helps you figure out that's not an answer. That's just ridiculous. You can always do that on math tests, and especially SAT questions, ACT questions, when you get to them. You want to use that with the multiple choice. Okay, so there's a word you're going to learn today. It was on the screen before, and it's called conjecture. A conjecture is an unproven statement based on observations. I'm going to make one today, so go ahead and write down. We actually do these about each other a lot. So you want to be writing this down. You already wrote it down. Interesting. All right, so let's see, what is one? This class isn't really that bad. So like in my first hour classes, there's a kid who's consistently tardy. So I would say, Colt is always tardy to class. So what can we assume about tomorrow?
He'll be
tardy to class, because that's based on observations. You actually do that all the time with each other. Well, she always does this. Okay, that's a conjecture. It's not really proven, but it's based on observations. Ms. Marshall Ms. Marshall wears polos when it's a game day. Okay, that is based on observation. So guess what you think today is? A game day, because she does not just wear polos to wear polos. Okay, so that's a conjecture. You make them all the time, based on an observation of other people, or about school, or classes, things like that. Okay? So you're going to learn how to use inductive reasoning, deductive reasoning. Here we go. Inductive reasoning, the process of looking for patterns and making conjectures. And I also want you to write one more thing when you get there. So this is the process of looking for patterns and making conjectures. I also want you to put in parentheses, you're looking at behavior. So please put in parentheses that you're also looking at behaviors. So again, put in parentheses that you're looking at behaviors. So inductive reasoning says, hey, I did well on my quiz. I've done well on my homework. What can I assume about my test?
You did good.
I'm going to do well on my test, okay, because of my past behaviors, okay? So later on, we're going to learn a second type of inductive reasoning, or a second type of reasoning. But inductive, you use on those pictures that we started class with. Those are inductive reasoning. Okay, so to figure out how to solve inductive reasoning, there are 3 stages. You have them on your paper. First one is look for a pattern. So you look at the several examples they're given, diagrams, tables, to help discover the pattern. So that's step 1. You just want to write what's in black. Look for a pattern. Next one, make a conjecture. Again, a conjecture is an unproven statement that is based on observations. All right, and then the last, to verify the conjecture. What does verify mean? Make sure it's right. Fact check it. Use logical reason to verify that the conjecture is true in how many cases? All cases. Okay, so it can't be true in some and not in all. Okay, so is the conjecture that Colt is late to class every day, is that like a 100% true conjecture? No. Okay, you're going to learn what's called a counterexample. You're going to learn it later. Okay, and we're going to talk about it. All right, so let's do these examples. They're on the next page. Describing the pattern. Well, sorry. Actually, we're just using inductive reasoning to draw the next 2 shapes in the picture. Okay, so here we go. We have 3 shapes. We got a square. What would you call the middle one?
A diamond.
A diamond. And the next one? Square. So let's do this step by step. What would the next one be then? A diamond again. So you want to draw it. Then you would have a square. All right, from here we want to look at, we have this double curve. Okay, it's in the top left. All right, where does it go next? Well, it goes top middle. Then it goes top right. So if it follows this pattern, where would it go next?
This side.
Well, it's more like the side here. You're good. And then after that, where would it go? The bottom right. Yep. All right, now we look at this dot. This dot is in the bottom left. Then it's in the bottom kind of middle. Then it's in the bottom right. Then what would it do?
The side.
Yeah, this side. So it'd be right next to the double dot. Or the double line, sorry. All right, and then it moves one more time, and it would move to, yeah, the top right corner. Done. The next, so see how, did I do all of that all at once? Did I just say, oh, nope, this is going to be the next picture? Okay? I didn't, and guess what? I'm a geometry teacher. I still have to do it step by step. I did the outline first. I did what I outlined in orange second, and I did the blue third. Okay? I did it step by step. You should do that too. Okay? Number 9, we got a bunch of squares that are being cut up. So what can I assume about my next two shapes?
They're gonna get cut up.
Yeah, they're going to be cut up square type things. So it goes one whole square, cut into 2, cut into 4, cut into 8. So what's happening?
It's multiplying.
Multiplying by 2. It is getting, the boxes are getting smaller. So how many are going to be in the next one? 16. 1, 2, 16. The next box, how many would there be? If we had 8 and then 16, we'd have 32. Here's the thing. Well, none of us have time in our lives to draw 32 boxes. So we're going to write the words 32 boxes and use our imagination. Is that okay with you? You did a good job. I would rather not draw 32 boxes. I'm sure you would rather not. Are we all okay with the fact that there will be 32?
Oh yeah, Miss Marshall.
Okay. All right, the next one, it's an X and Y axis. Ta-da. Okay, so here we go. We have, this is quadrant 1, quadrant 2, 3, 4. Do you remember this from, oop, that's 6. Do you remember this from algebra? Okay, good. So I'm going to refer to them as 1, 2, 3, 4. Okay? So we have a point in quadrant 1, 3, 1. Then we have a point in quadrant 2, it's negative 1, comma 3. Then we move to quadrant 3 with negative 3, negative 1. So which quadrant are we going to be in next? Quadrant 4, which is over here. All right, so we're going to have a dot somewhere in here. Here's what we also need to observe. We go from 3, 1. Which quadrant is directly across from quadrant 1?
2.
Across from it?
Oh, 4.
Across from it?
Yes.
Like vertical. That's what I was thinking. 3. What do you notice about those two numbers? Diagonal. Same thing as vertical. Are vertical angles? Vertical angles share a vertex. Look at this. We got 3, 1 and negative 3, negative 1. Okay, they're the same except for in quadrant 1, every single point is positive and positive. In quadrant 3, every single point is negative and negative. Okay, but they're the same order, 3 and 1. Do we agree?
Yeah.
So what we want to look at is, because our next one's in quadrant 4, which quadrant is directly across from quadrant 4? 2, which would be negative 1, 3. Here's the thing. We want to use those two numbers, except for the fact that if my x, I go to the right to become in this quadrant, so is the right positive or negative? Positive. And then I have to go down. Is that positive or negative? Negative. So my next point is 1, -3. Then after that, we don't want to overthink this. After that, what happens? We're back where we started. So this whole thing would be the next one. Because it starts back over. Ta-da! All right, we're going to make and test a conjecture. Here are the next example. I want you to take out a highlighter. A highlighter. When it says make and test a conjecture, you're going to feel a little bit like it is. It's okay if you have to borrow one or underline it, whichever one you want to do. It's going to feel a little bit like science class, just a smidge. Make and test a conjecture about the science. So when it says make and test, you're going to make 3 tests. 3 tests. I'm explaining how to show your work and then what your final answer will end up looking like. You're going to make 3 tests about the sign of the product of any 3 negative integers. About the sign of the product of any 3 integers. We're going to talk about all these words. Review them. Okay, so it says the sign of the product. What does product mean?
The final answer.
Final answer to what?
A multiplication.
Multiplication problem. So we're going to be multiplying how many numbers? 3 numbers that are what? Negative. 3 negative, what is an integer?
It is a number.
It's a number. We're going to be multiplying 3 negative numbers. So here's what you want to do. We're going to create 3 tests. You need at least 3. You're going to make a conjecture, an unproven statement based on these 3 tests. I will explain when we get there. So you see how I wrote test 1, test 2, test 3? That's where I'm going to write my different tests. We're going to multiply 3 different numbers each time. So pick a number. -7, sure. Pick another one.
2.
-8 and -2, sure. We're going to multiply all 3 of them together and see what our outcome is. What's -7 times -8? 56. Times -2 is negative.
102.
Yeah, 102. There's our first test. Our second test, we want to use different types of numbers. Okay, let's use numbers. Let's use small numbers.
-1 times -2 times -3.
Sure, sounds good. So we got -1 times -2, which is 2. Positive 2. 2 times -3 is -6. All right, look at our answer. Our answer is -6. Okay, are we noticing a pattern?
No.
Even.
Oh, they're not always even. Let's try 3 negatives, 3 odd numbers together. Odd and negative.
9, 3, 7.
Okay, you need to take out your calculator then.
11.
Yeah, 9.
And 11.
11.
Okay.
11.
Okay, well then you're taking out your calculator because I'm not doing 27 times -11.
Or
Hustle, you got it. So what's -9 times -3? 27, positive 27. Then what's 27 times 11? 27 times...
297.
Yeah, -297. So up until then, yes, they looked like they were also going to be positive. Okay, they were also going to be even. But here we have a negative outcome. So look, the sign, we're looking at the sign of the product of any 3 negative integers. What is it always? It's always negative. So look at what my answer is going to be. Do you see how I wrote the sentence? The sign of the product of any 3 integers is... Then I'm going to put negative. This is my final answer. Because what grade are you in? 10th grade. You're going to write a full sentence. The only part that I came up with is the conclusion. Everything else I literally copied. It's underlined in orange. Okay, the sign of the product of any 3 negative integers. So here is what I'm going to tell you. Some students Try to use the same number over and over and over again. Is that going to be an accurate test if I just use the same 3 numbers and mix them up and mix them up and mix them up? No. Do you know the definition of idiocy?
Being an idiot.
Doing the same thing. This is what Albert Einstein said. Doing the same thing over and over again and expecting a different outcome. Okay? You want to be as diverse as possible when you're doing these problems. So we did somewhat larger numbers, we did small numbers, and then we did all odd numbers. Okay? Yes, sir. Can you do it at the end? We're almost done.
I'm at the end.
Make and test a conjecture about the product of a negative and positive integer. So what do you think my sentence after I make and test a conjecture?
The product of a negative integer and a positive integer
Is, yeah, that's exactly it. So go ahead and write that. The product of a negative integer and a positive integer. Again, what does integer mean?
It's a number.
It's a number. And we're waiting to fill in this blank. Is, we don't know yet. How many tests do we have to make?
3.
3 tests. You can make more if you want, but you have to do at least 3. Test 1, test 2, test 2, test 3. Okay, I don't have super amount of room. We want to do a product. What does product mean again?
The answer to
Multiplying a negative integer and a positive integer. So let's pick where the bigger number is negative. Pick a number.
Five.
Negative 6. Pick a number smaller than 6. 4, sure. So negative 6 times 4. Here I'm doing it where the larger number is negative, the smaller number is positive. We get negative 24. All right, now let's do it where the smaller number is negative. So pick a small number.
2.
Sure, negative 2. Sorry, I heard us first. Now pick a larger number. Sure, 6. Negative 2 times 6. Yeah, but it's not the same exact set of numbers. It's also so negative 12. Here we go. Now let's do 2. All of those were both even. Let's do 2 odd numbers.
Positive 12 because 7 is bigger.
You're multiplying, so the outcome will still be
7 and 3.
7 and 3. Sure, we can do negative 7 times positive 3, which would be negative 21. So what do we realize about all the answers? They're going to be negative. Ta-da! There's my answer at the top. So when you're doing these, you need to make sure you understand what the words mean. What does sum mean? Addition. What does difference mean? What does quotient mean? Division. Product? Multiplication. Absolute value. The bars, but what do?
They make it positive.
Close. They make them positive. Yeah. They make everything positive. Okay? Here's the last word we're learning is counterexample. Actually, sorry, I lied. It's 2 more words. Counterexample, a specific case for which the conjecture is false. So if I said Colt is late to class every day, I would say my counterexample is today. Colt was not late to class. So you have to come up with a specific case or specific instance where that's not true. The New England Patriots always beat the Jacksonville Jaguars. 20 to 31. I don't think so. That's not true. Yesterday, boom, case. So you have to show me an exact example why it is not true. Okay? And that's where we'll lead up to our next example, which is on that next page that we were on. You'll be okay. A student makes a conjecture about absolute values. Find a counterexample to disprove the student's conjecture. So if we're disproving it, can your answer be, actually they got it correct? No. If I'm telling you to disprove it because it's false, are you smarter than the book or smarter than the problem and saying, nope, it's right? Please don't do that. People do that all the time. They're like, no, I can't find anything wrong. Then keep looking because something is wrong, okay? She says, or he, whoever this person is, the absolute value of the sum, so absolute value, remember, looks like this, of the sum, again, what is that? Addition of 2 numbers is going to be equal to the sum of those two numbers. Okay, let's pick two positive numbers. Let's start there.
1 and 2.
Sure, 1 and 2. What's 1 plus 2?
3.
What's the absolute value of 3?
3.
3. All right, over here we add 1 plus 2, which is 3. Does 3 equal 3?
Yes.
Yes. So in that case, we did not disprove anything. We just literally confirmed what she thinks. Or he. I don't know why I think this is she. Maybe because I'm a she. I don't know.
You said he at first.
Well, I said she, and then I was like, oh, that's terrible. I'm assuming that. Let's do two negatives. Okay, pick a negative number.
-1.
Negative 1 and 6, sure.
-2.
All right, well, I already did it. What's negative 1 plus negative 6?
That's negative.
What's the absolute value of negative 7? 7. So we have 7 as one of our answers. The other, if we just add negative 1 and negative 6, we'd get negative 7. Do these two match?
No.
No, $7 in my bank account is much more preferred than negative 7. So literally, your counterexample is exactly that. That's a counterexample. Boom, exact example. Guess what? You're going to have different types of answers. Okay, we could have also done where one of them is negative. How do we add two numbers and get a negative outcome if one of them is negative? Which one would have to be negative?
The bigger one.
The bigger one. So if I said negative 5 and 2,
Yes.
that's her. That means the absolute value of negative 3, which is 3. If I just add them, okay, here would have been another counterexample where the absolute value of two numbers added is not equal to.
The sum of two numbers.
Wait.
You know what she means.
Yeah.
What did I put?
You said 5.
Oh, sorry. I meant 2. I'm sorry. I thought you were confused about the concept. So this would have been another counterexample. Okay, there are many, many answers to these type of problems. Okay, we have one more thing. We already knew inductive reasoning was based on previous examples and patterns. Deductive reasoning uses facts, definitions, and accepted properties. So that's all I want you to write. Deductive reasoning uses facts, definitions, and accepted properties. These are stone cold true facts. Okay, not, oh, I watched this happen, so this must be true. It is 100% true. This is usually the more accurate. And I will give you an example. Okay, example. Let's use these three. Okay, let's say that Mackenzie is a senior, Justin is a junior, and you are a sophomore. Tia is a sophomore. Usually, seniors are older than juniors, yes?
Yes.
And juniors are older than sophomores. So because of that pattern, I would say that Justin is younger than Mackenzie. And Tia is younger than Mackenzie. And younger than Justin. Because of that pattern. That's based on an observation. That's based on, not really behavior. Okay? Facts would be, Mackenzie is, pretend these ages, 16. Justin is 15. Well, there you go. Tia is 14. Okay? So because of those facts, Tia is obviously younger than Mackenzie. Because of a fact. Not because, well, Tia's in a lower grade. So, does that make sense?
Yes.
Facts are more, accurate. Okay? If I say that Justin's mom every day after school gives him an applesauce pouch, what will she do tomorrow? She could give him an applesauce pouch, or she could be like, nah, Justin, you don't deserve that today. Or, sorry, I didn't go to the store. I have to give you a cheese slice or something. Okay? So, I don't know. But inductive is based on those behaviors, whereas deductive is straight up facts. Decide whether inductive reasoning or deductive reasoning is used to reach the conclusion. Explain your reasoning. Now think about this. Letter A. It says each time Monica kicks a ball in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Does it mention the word gravity in this?
No.
No, but what is she discovering?
Gravity.
Gravity. But here's the thing. Do we know how old Monica is?
No.
No. Does, let's say, a 2-year-old, do they know what gravity is?
Oh.
She could be discovering this for the first time. You are in 10th grade. You know what gravity is. So you're like, no dip, Sherlock. What goes up must come down. She's like, oh my gosh, Mom. Oh my gosh, look, I kicked the ball. And it comes down. Look at that, okay? So what is she doing? Is she using facts? Or is she just watching a behavior, watching a pattern?
She's watching the pattern.
She's watching a pattern. She's watching. Look at what I kick it and it comes back. It's like magic. Okay, look at me. So this is inductive reasoning. 100% inductive reasoning. Had it said, Monica read about gravity in physics class. So she no. Okay, here she's literally. Well, you know what I mean. You know what I mean. She's smart. She's working it. You know.
She's what smart cookie.
She is. So, letter A, inductive reasoning. Letter B, and the reason is because of that pattern.
She's patterning it.
Patterning it, yes. Good.
I really gotta use words.
All reptiles, letter B, all reptiles are cold-blooded. Are any of us contesting this?
I got it. No.
Okay? Parrots are not cold-blooded. I agree, okay? Sue's pet parrot is not a reptile.
It's a fact.
These are all facts, okay? Based on these facts, we can conclude that her pet parrot is not a reptile. So this is deductive reasoning, okay? It doesn't say, well, Sue felt her parrot and he felt too warm to be cold-blooded. Okay, no, it literally says parrots are not cold-blooded, all reptiles are cold-blooded, so her parrot is not a reptile. Okay, so that was deductive reasoning. That is where we're going to stop for today. You're going to begin on this classwork. It is 1 through 15 all. You can also work on the review section. This will be due tomorrow, as we'll finish the rest of the lesson tomorrow. What's that face, Alana?
I don't know about this.
Okay. You may go to the restroom, Cole. Thank you.